Hello and welcome back to Chapter 2. An easy chapter this one. We're going to get started. First off, I'll give you an overview of the support process for the course. If you hit problems and you can't carry on, our support team will help. Then we'll get your development environment in shape. We'll start a database and get the initial workspace set up. And if you need it, I'll spend about 45 minutes on an overview of SQL. It will only be basic, but enough to get us through this course. Just before we start setting up the environment, I'd just like to say a few words about the support for this course. We're really keen that if you hit problems, we are here to help you get going again. But before you do contact us if you hit problems, the first thing you should do is go back to the course webpage at the URL you can see here at virtualpairprogrammers.com. And there is an errata tab on the page there. And what you will find there are any errors that have been reported against the course. And we'll always keep this up to date. Now, of course, we can't see anything there just now because I haven't yet released the course, but once it's up and running, there'll be a fair few reports in there. Also, over time, I'll be blogging about the content of the course. And from this link, there'll be a list of blog posts that are relevant to the course. For example, I might add some extra material and you'll find details of it there. If you are stuck on the course, then you can follow the contact link and just fill in the form and we'll get back to you as soon as we can. Now, we promise we will get back to you, so don't panic. But we do have a small support team. They're always very busy, especially near a course release. So please don't worry if we take quite a long time to reply to you. I promise we will get you going again. Now, the support we can offer is relatively limited. Obviously, any of the course content we're here to help you with. And if you get completely stuck and you're getting a crash that you're not expecting, then we're determined to help you. We can't help you with kind of anything beyond the scope of the course, and we certainly can't help you with any project problems that you have once you've finished the course. But please don't hesitate to contact us if for any reason you can't move forward on the course. I'd hate to think of you sat there tearing your hair out in a real panic. We've tried to cover as much as possible on this course, and so it's been a really, really long course, but even so, there will be things that we can't quite cover. So I will be showing you the Hibernate reference manual, where you'll be able to go further with your Hibernate. But a great resource, I'm sure you're probably familiar with it already, is the Stack Overflow website. A great question and answer site for developers of any persuasion, really. But one of the great things about this is it's really easy to effectively ask questions like, can I use Hibernate with stored procedures? And you'll usually find some good answers for those questions. Now, as it happens, stored procedures is one thing that we're not going to cover on this course. So I suggest Stack Overflow is a really good starting point when you want to go beyond the scope of the course. But anyway, let's get back to the course. The first job we're going to do is we're going to set up your development environment. Now, this is probably one of the hardest things that I have to face on a course, that I can't see you and I can't see your desktop environment. So what I want to do is I want to try to make what you see on the screen as close as possible to what you're doing at home. And I strongly recommend as you go through this course, the whole idea of the course is that we're going to be pair programming, which means that the code that I have on the screen, you're going to be following along and doing the same kinds of things in your development environment as I'm doing. Of course, you can just sit back and watch the video, but I don't think you're going to learn nearly as much as if you've actually got Eclipse open alongside your video. If you're in the lucky position where you have two monitors, then obviously you can play the video on one monitor and have your development environment in the other. Over the course of this video, I'm going to show you the steps you need to follow to get your environment up and running. And the first thing you need to do is to download the Practicals and Code folder from our website. You'll find that folder as part of your course package. If you go to the My Courses link, find the Hibernate course, and then find the Practicals and Code folder. And of course, if you're using the DVD edition of this course, you'll find all of that on the DVD itself. And you should find 4 folders in there. The first folder contains all of the software that we're going to use for this course. Well, actually, there's only one piece of software, and that is the Derby database. I'm using this database on the course because it's trivial to set up and configure. Now, I know a lot of you will be wanting to work on other databases like MySQL. That's probably the most common one that we get asked for. But I'm strongly recommending that you work with the Derby database that I'm supplying, just so I know what kind of environment you have at home. Then my support team will be able to help you much more easily if you run into problems. You can use MySQL, but I think the best thing to do is to go all the way through the course, and I promise you it's just a case of changing a few values in a config file to point it to a MySQL database. Some people think Derby is some kind of a third-rate database, but it really is a proper database. It came originally from IBM, and it has all the features you'd expect from any regular database. So all you need to do to install this is to copy that folder to somewhere on your hard drive. If you've unzipped the Practicals and Code folder, then you can run the database from that folder. But just to keep things easier, I'm going to copy this Derby folder into the root of my C drive. As I say, you can put it anywhere you like. Okay. The downside of working with Derby is you do need to use the command line to work with it. So on Windows, just use the Start menu and type in CMD, and you'll get a command window. If you're running on Mac OS or on Linux, then you'll just go to your terminal application to do exactly the same thing. Once you've done that, just navigate into the folder in which you installed Derby. So for me, it was the root of the C drive and then the folder called db-derby, and then change directories into the bin directory. And then you're looking to run the script called Start Network Server. I can do that easily on this command window. If I just type ST and then hit the tab key, that will autocomplete because it's the only matching file name. And Start Network Server, when you run it, should give you 2 lines of logging. The important one is the second one, which says we are started and ready to accept connections on port 1527. That's all there is to running the Derby database. And you just need to leave this running in the background throughout this course. And don't forget, every time you start a new chapter or you've gone away for a bit and you've rebooted or something, you do need to have this running in the background or you'll get all kinds of ugly errors. Next, if you could pop up another command window and navigate into the same folder again, db-derby, and the bin directory. The next tool we're going to run is the IJ tool. Now this stands for Interactive JDBC. And what we can do in this window is we can issue SQL against the database. And we're going to do that a lot on this course. We'll be inspecting the contents of the database directly through the IJ tool. But there is one step you have to do first, and that is you have to connect to the database. Now, I'm sorry that this is a little bit clunky. You need to do connect, and then in single quote marks, you need the phrase JDBC :derby ://localhost. And that just means the database is located on the same machine as we're currently on. And then /my database. And then finally, a semicolon and create equals true. Then a single quote mark and a semicolon. And this just means connect to this database, but if it doesn't exist, you're happy for Derby to create it for you. So if I hit return there may be quite a long delay here. And if you get any warnings about firewalls, please click on Allow Access. You should get a cursor back with no errors. Now at this point, if you've got errors, then do drop us in a support call because you can't really go any further on the course. And we'll get back to you as soon as we can. We might not be quick, but I promise we will get back to you. Let's just issue a command here, and I think I'm just going to go for show tables with a semicolon, and that will show you all of the tables currently in the database. Well, we haven't created any yet, so you get a load of system tables. I don't really know what these are all about, and I don't care either. We'll never use them on the course, but if you can see this output, then all is well. When you're finished with the IJ tool, you just exit it by typing exit and semicolon. Now, by the way, once you've created the database, on future runs, when you go into IJ, all you need to do this time is to connect to jdbc :derby //localhost /my database, or whatever you called it in the previous step, and you do not need the create equals true, because the database has now been created. And just if you're interested, if you look in your Derby folder and you go into that bin directory on Windows Explorer or whatever file manager you have, you'll find that you do now have a folder called My Database in there. And in fact, that is the database. All of the data you're creating on this course is going to go into that folder. If ever you get in a complete mess on this course and you want to completely wipe the database, then you can close this window, delete that folder, and then start up the server again, and then go into the IJ tool and use the connect string with create equals true, and you're back to where you started. Going back to the practicals and code folder, the next thing we'll need is a workspace in which to work through this course. Now, in a similar way to I was talking about with the database, it would be far better if you could use the same development environment that I'm using on this course. Now, I'm going to use Eclipse, not because I particularly prefer Eclipse, but just because it seems to be the one that's most commonly used. I really am just going to use Eclipse as pretty much a fancy text editor. I'm not going to use any features, really, in Eclipse. So I promise you could do all of this work in any other development environment. But again, to make support simple, I recommend you use Eclipse. If you want to use NetBeans or IntelliJ, then feel free, but we might not be able to help if you hit an IntelliJ or NetBeans specific problem. A good thing to do possibly might be to run through the whole course on Eclipse and then to kind of convert it into the development environment of your choice. You don't have to, but it would make support easier. But anyway, on the practicals and code folder, there is a folder called Starting Workspace. And although I've called it a workspace, there's actually nothing special in there. There's a folder called Hello Hibernate, which is going to be the name of our project. There are some extra files in there that we'll pick up later in the course. They're just kind of some pre-written files to save you some typing. But if you look in the Hello Hibernate folder, you'll see that we have an empty bin directory. We have a lib directory with, I think, about 10 or 12 jar files in there. And in fact, they're all the jar files you need to make Hibernate work. So on this course, you don't have to go away and download anything, and you don't have to configure a build tool like Maven. They're all there ready to use. Then there's an SRC folder which contains our source code, but you're going to write most of the source code. I'm not giving you a lot of pre-written code. There's an XML file there, which is a very basic skeleton configuration file for Hibernate. We'll be filling that in shortly. And in the com folder, there is a package that you can drill down to, and there's a starting file called student.java. But really, there's not much in there at all. So again, if you prefer to work with a different development environment, that's fine. You just need to pick up those jar files and get the source code into the right place. But if you're using Eclipse, all you need to do is fire up Eclipse, browse to the Practicals and Code folder, into the starting workspace, and then just open up that folder. I'm using Eclipse Indigo for the course, but again, it really doesn't matter which you use. You can close the Welcome tab down. You'll probably start with an empty package explorer. The first thing you need to do is to start a project or to import that code into your project. Now, this is ridiculously complicated in Eclipse, and I think the best way of doing it is to follow these steps. Go to the File menu, select New, and then select New Java Projects. That might feel a bit odd because the code already exists, but it's a new project in this workspace. The trick is, for the project name, you have to type exactly the same name as the folder name that we have in our workspace, which, if you remember, was Hello Hibernate. And it is case sensitive, so be careful to get that exactly right. If you've got Use Default Location ticked, you should now have an info line saying the wizard will automatically configure the Java runtime and the project based on the existing source. And what that means, if you click Finish, is that it's detected that we have a source folder and that needs to be compiled. It's detected that you have a lib directory and that all of these jars are on your build path. And so you should find them all also appearing under referenced libraries. So you're good to go. Feel free to have a little explore around there, but you'll see that the one Java file we've given you is a very basic Java class. And what we'll be doing in the next chapter is we'll take this class and we'll make it work under Hibernate. If you've got this far, then you're ready to move on to the next chapter. If you've had any problems, I'm really keen that you get in touch through the contact page on our website because I'd hate to lose you at such an early point in the course. So you're now ready to move on to the next chapter, but what's going to follow in the next few minutes is a quick overview of SQL. Now, this will be a very basic overview. It's kind of intended just to teach you the SQL that you need to get through on this course. But it really isn't much. We'll do a few selects, a few inserts, and a little bit of joining. If you're already familiar with that, then you can safely end this video and move on to the next chapter. Welcome to this short extra item where I'm going to give a quick introduction to SQL. It won't be a comprehensive introduction because that's not what this course is all about. I'll be covering here all of the SQL that you need in order to get through this course. SQL stands for the Structured Query Language, and it is the standard way of reading and writing directly to a relational database. And really, any relational database is going to support SQL. On this course, we're going to be working with the data for a college, or a university, or a school. So the obvious kind of entity that I want to be keeping records about are students. So this graphical table here is just showing a list of the students that I have in my college, and I want to store all of their names and all of their enrollment IDs. Now, the fundamental concept in a relational database is actually quite natural. It's called a table and is designed to model exactly what we have on the screen here. We're going to have a table in our database called students, and the table is made up of several columns. Each column is a field of data, so naturally our columns are going to be name and enrollment ID. And the table itself is going to be called students. So make sure you have your database running as described earlier on in this chapter and pop up that IJ command prompt. And this is how we're going to be able to issue SQL statements to our database. And if we type in the command show tables, in fact, this isn't really SQL, this is just a command that the Derby database recognizes. Make sure you have a semicolon at the end, and that gives you a list of all of the tables that currently exist in the database. Now, these tables are all system tables. They're kind of built-in tables that Derby uses internally. So the important thing is that we haven't yet created any tables. We need to be able to create a table to hold students. Let's have a look at the syntax to do that. This is the command to create a table in a database. And, not surprisingly, the command is create table, followed by the name of the table that you want to create. Now, I'm just using all lowercase letters here. The database that we're using is not case sensitive, so it doesn't really matter what we use here. You'll probably find that many projects will either use a capital first letter, or some projects even use all capital letters for table names. Feels a little bit legacy, but it's still quite common to do that. I should also mention that some projects will use plurals for table names and some will use singular. So I've used student here, but you'll find it's quite common to use students. That's entirely up to your project. Then in the round brackets, we're listing all of the columns that we want to appear in this table. So we have name and then enrollment ID. But after the name of each column, here we have name. The next item is the data type that we want to store this data in. Now, of course, you're used to Java strings, but in databases, the data type actually varies from database to database, but it's usually a data type called varchar. And in the round brackets, we have to specify what the maximum size of that string is going to be. Now, that's important in a database because we're effectively defining here how we would like the data to be laid out on a hard disk. So we have to give a physical size of each string. So obviously you've got to make that big enough so that you don't get truncation, but equally you don't want to waste space on your hard disk either. Similarly then for enrollment ID, this is going to be a varchar, but I've made this one 25 because there are fewer characters in enrollment IDs. So we can do that then directly into our IJ prompt. We create the table. I'm going to use an uppercase here just to make it clearer. Student, and then round brackets. The name is a varchar with 300 characters, maximum, and the enrollment ID is going to be a varchar of 25 characters maximum. And all being well, it's saying no rows were inserted, updated, or deleted, which is a bit vague, really. That should be saying that a table has been created, and we can prove that. There's our new table called student. Another command that's not part of SQL, but is part of this database, is we can describe our student table. Don't forget the semicolon, but that will give you a list of all of the columns together with the information such as how many characters can they hold. Well, the next obvious thing to want to do once we've created a table is to get some data into the table. And we do that using the SQL insert into statement. So we specify that we want to insert into, followed by the name of the table that we're writing to. Then, in the round brackets, we list the names of the columns. Now that's because when we're inserting, we can insert the data in any column order. I could do the enrollment ID first and then the name, or I might just insert an enrollment ID into the table and leave the name blank. That's why we need to list the column names here. Then we follow with the keyword values, and then in round brackets, the data that we want to enter. Now notice that these strings need to be in single quote marks. It won't work if you use double quote marks. So we'll give that a try. Insert into student. name and enrollment underscore ID, values of Frank Jones, and I've used a double quote mark there. Make sure these are all single quote marks. And by the way, these enrollment IDs that I'm using here, I'm really just making up for now. We'll talk a little more about those later in the course, but this is some kind of just unique string that our software is going to generate for each student in the database. If you've got syntax correct, then it will say one row inserted, updated, or deleted. If you get any kind of a syntax error, like using a double quote mark there, oh, well, actually, if you use a double quote mark, you'll get this kind of hang because it's waiting for you to close the double quote marks. Eventually, you will get the error you can see here. Let me try another syntax error. I'll talk more about that in a minute. Let's say we've used the word value there. Then, again, you'll get the error 42x01 syntax error. One common thing to forget is to, if I just go back to my valid SQL there, if you forget the semicolon, then the command prompt will think that you want to enter a further line of code. So if you do that, you can just simply put a semicolon at the end there, and that will cause that row to be inserted. I've just accidentally inserted another row for that student, but never mind, I'll come back to that in a few moments. So once we've inserted, the next natural thing is to want to get the data back from the database, and this is a select statement. With a select statement, we can get back a collection of rows from the database. Now, I only want, in this case, the name of every student in my college. So the syntax is select, followed by the column name that I'm interested in, from student. And that will return me every row in that table. Let's give that a try. So select name from student, and there are our two students. Now remember, I accidentally inserted an extra student in the previous example, so I'll come back onto that shortly. Something else I've not mentioned is that on this command prompt, you can always use the up arrow on your keypad. That will recall the last statement that you issued. And you can keep pressing it to keep going backwards, and you can press the down arrow to go the other way. So I've just recalled the previous statement. Now, we don't have to get one single column back. You can specify after a column enrollment ID, for example, and that will bring back the name and the enrollment ID for every one of our students. But a very common shorthand is to use an asterisk on the select statements, and that means get all of the columns back from the table. Well, for us, we only have 2 columns, but of course, if there were 100 columns in this table, then that single star or asterisk would bring all of the columns back. Let's add in some more data to make this more interesting. So we'll insert into the student table, specifying the name and the enrollment ID, the values of Alan Matthews. They have the enrollment ID of 1-MAT-2008. And I'll be lazy and just recall that command and then plug in the data for Claire Thompson. And her enrollment ID is THO 2007. And finally, we have Suki Webster with an enrollment ID ending in 2006. So now I can select all of the columns from the student table, and I have a slightly more interesting report. And we can add a so-called where clause into the select statement. This statement here is saying that I want to get all of the columns back from the student table, but only for the rows where the name is equal to the value of Frank Jones. And I can use various operators such as where the name is not equal to, and if we have a numeric value, we can get all of the students whose age is greater than a certain value and so on. But for now, I'll just try that out with select all columns from the student table where the name is equal to Frank Jones. And we're at the moment getting 2 rows back for Frank Jones. Of course, we will want to be able to update the data once it's in the database. So this statement here is the update statement. It's saying that we want to update the student table and we want to change the name via this set name to the value of Francis Jones, but only where the enrollment ID matches the string you can see there. Now, if we didn't have the where clause, this would change the name of all of the rows in this table. So you have to be very careful with an update statement to make sure that your where clause is targeting the correct rows. We can give this a try. Update student, set the name to be Francis Jones, where the enrollment ID is equal to 1-JON-2009. That's telling me that 2 rows have been updated. And if I repeat my select, I think I'll do the select all the columns but get all the rows back. You can see now that student's name has been changed correctly. Now, one of the rules of databases is that every row in the database should be unique. If that's not the case, then we'd end up with some very confusing situations. Now, actually by accident a few moments ago, I accidentally created 2 rows with the same name of Francis Jones and the same enrollment ID. Now we have a real problem, because if these are different students who just happen to have the same name, then I can't update these students independently. You've seen that if I change the name of one of them, then the other one will change name as well. And also, I wouldn't be able to delete one of these Francis Jones and leave the other one in place. The syntax for deleting, by the way, you've probably guessed, is delete from student where we could use enrollment ID equals 1-JON-2009. Well, that's going to delete both of those rows. And it's possible in real life that these 2 Francis Jones are actually different students. So this is an important rule in relational integrity. It's called integrity, that we keep the data completely clean, and we need to make sure that every single row has at least one unique column that identifies that column and makes it completely different from all of the others in the table. Now, we could have used enrollment ID to do that. Now, after all, I would guess that in this college, we're going to make sure that every single student has a unique enrollment ID. That certainly makes sense. So that was my real mistake here. I should have given these 2 Francis Jones different enrollment IDs. But it turns out that because enrollment IDs are generated by the business, they can sometimes cause problems with databases. And I will talk more about that later in the course, but you're going to find that many databases will have a so-called primary key in the table. And often, the primary key is nothing more than an integer. It doesn't have to be an integer, but it's a common choice because that can be generated very quickly. In order to set up a primary key effectively on this table, unfortunately, I'm going to have to remove the table and start again. It's actually quite hard to put a primary key on a table once you've created one. It is possible, but not in the way I want to do it. So it gives me a chance to show you the syntax for removing a table from a database is the drop keyword. Drop table student will remove that entire table and all of the rows in the table. It's a bit confusing that this database says there were no rows inserted, updated and deleted. Well, Technically that's true, but since the whole student table is now gone, we've actually lost 4 rows. So what I'm going to do this time around is recreate the table, but this time with an ID field which automatically increments every time we add a new row. And then we're always going to get at least one column that uniquely identifies each row. Let me show you how to do that on a caption. The syntax looks like this. It's the create table syntax as before, but this time around we have an ID column. We're going to use the data type of integer, which is a data type on the Derby database, but I've added the generated always as identity. Now it's quite waffly, and I'm just working with the reference manual of Derby here. That tells Derby that each time a row is inserted for students, it must add in an automatically incremented ID. Now that syntax varies from database to database. If you were on MySQL, for example, you would use something different. Let's check that it works here. So the ID is going to be an integer. It's going to be generated always as an identity. And the rest is as before. The name is a varchar 300 and the enrollment ID is a varchar of 25. So no errors there, and I can describe the table. Let's insert our student again. So insert into student. Now I only have to specify the name and the enrollment ID. I don't need to give the ID, that will be automatic. And then the values of Frank Jones and the enrollment ID as we did before. I've missed a single quote mark on the end of the line there, so unfortunately the only way out of that is to add it here on the next line, let it crash with the syntax error, and then recall the command and then just edit it. Sorry about that. But we've now got a row inserted, and if I select all the columns from students, you can see now that we have an ID of 1 for Frank Jones with that enrollment ID. And the important aspect of that is if we were to accidentally now repeat that insert, a bit like I did earlier, well, I didn't mean to do that. So if we do a select again, well, this time around, although most of the data is identical, we've always got that ID field, so I can always get in there and delete from the student table where the ID is 2. So I can always undo my mistake, and I couldn't do that before. Now, I won't talk much more about these IDs. In fact, what we've seen here is an example of a primary key, the primary way of identifying rows in a database. And you can actually set a flag on that column to tell the database it's a primary key. And then the database can kind of perform some optimizations. But I won't bother doing that here as long as you know about the concept of a primary key. Now, I also need to store for every student a tutor to supervise them. And in this particular college, every student will only have a single tutor supervising them. They might be taught with different subjects by many tutors, but the supervisor is a single tutor. So I could do the following. Here I've got each student, such as Frank Jones, with their enrollment ID, and I've marked in a new column the name of their tutor. But this is really bad. It violates one of the principles of databases, which is that data should not be replicated. Now, I want to be able to track the salary for each tutor, as well as their name. So notice here that because this tutor called Mark Watson is supervising 3 different students, I've had to copy their salary into 3 different rows. And of course this is bad because it might not get updated properly now if we have to update the salary for Mark Watson, we'd have to be careful to go to all three of those rows to update the salary. And it's just bad design, really, because these three Mark Watsons are the same tutor. So you've probably guessed that we need a second table just for tutors. So let's go into the database and add in a tutor table. It's going to be the same syntax as before, create table tutor. And we're wanting, once again, we'll want an ID column. And in general, we're going to have an ID column for every single table in the database. I can never remember the syntax for the auto increment. So it's integer generated always as identity. But then we can continue with the tutor's going to have a name. I don't need to say tutor underscore name because the name of the table tells me that this is data for a tutor. So we'll make that varchar 300 perhaps. And then they have a salary, which I'm just going to store as a simple integer. If we describe the tutor table, that all looks good. And we'll just quickly insert into the tutor table the name and the salary with the values of Mark Watson and a salary of 10,000. And I know it's boring, but it's good practice. We'll add in this other tutor called Pat Fay, and she has a salary of 12,000. Notice that the salaries are not in quote marks because they're integers. Then if I select all of the columns from the tutor table, and there they are. So we can now store students and tutors. We can't yet capture the information that says that a student has a particular supervisor. So here's our tutor table. And one possibility is that for any particular tutor, such as Mark Watson, we could list all of the IDs of the students that they teach in some kind of a, I don't know, comma-separated list. So we know from this that Mark Watson looks after the students of ID 1, 2, and 4, whereas Pat Fay looks after the single student with ID 3. But this is another bad thing to do, and this is violating another principle of relational databases, which is that a column should only hold a single piece of data, a single atomic piece of data. And just in practical terms, if we did it like this, we'd have to fiddle around with comma-separated lists every time we wanted to maintain the relationship between students and tutors. So the correct way to manage a relationship in a relational database is to really go at things the other way around. Here we have our student table. And remember that each student only has one supervising tutor. Therefore, I've added a new column into the student table, which I've called here tutor underscore FK. Now the FK here, it's very common to use that abbreviation. It stands for foreign key. And it means that the number in this column is referring to an ID in another table, a so-called foreign table. And of course, that foreign table is the tutor table. So we know now, just by looking at this table, that the student of ID 1 is called Frank Jones and is supervised by the tutor of ID 1, which is Mark Watson. However, the student of ID 3, Claire Thompson, is taught by the tutor of ID 2, and that's Pat Fay. And this way around, we only store a single piece of data in that column, and we don't have to have multiple tutors appearing in the database. By the way, if the student was able to have more than one tutor, then we'd be in trouble again, because then neither table would be able to hold the relationship. Now we'll be seeing how that's managed in chapter 11, but we don't need to worry about that right now. Let's go into the database and add this foreign key column. Before I do that, I need to show you the syntax of how to add columns to an existing table. And it's quite easy really, we just have to use the alter command. Alter table student. And we just say we want to add a column called tutor underscore FK, and that's going to be an integer. Don't forget the semicolon. And there we are. If we describe now the student table, you can see that the tutor foreign key has now been added to students. Now, if I do a select of all the columns from the student table now, well, unfortunately, this is one weakness of using Derby on the command line. When we have too many columns to display, it kind of all starts getting a little bit messy on the display. So I think for this, I'm going to do a select just the name and the tutor foreign key from the student table. The tutor foreign key is currently set to null. And I think this is the first time we've seen a null in the database. Of course, you're familiar with null from Java. This is similar but different in a way. Null just means there is no value inside this column. It just literally has no value. So that means at the moment that our student called Frank Jones does not have a tutor. So we can easily change that. We can update the student table. We can set the tutor foreign key to be 1. And we'll need a where clause. And remember, the ID of Frank Jones is 1. So that's where the ID equals 1. And then if I repeat that select, now we know that Frank Jones is being taught by the tutor with the key of 1. Let's now enter the rest of the data that we can see on the screen here. So we've already got Frank Jones in the student table. So we'll insert into the student table the name and enrollment ID and the tutor with the values of, first of all, Alan Matthews and enrollment ID of 1-MAT 2008. Oh, and not forgetting the tutor foreign key is going to be 1 for this student. And then I'll just recall that command. This is now going to be Claire Thompson. Her enrollment ID is THO 2007. And her tutor is the tutor of ID 2. And then finally, our last student is Suki Webster. Enrollment ID is that, and their tutor is tutor ID 1. Now I can see a little problem coming up. If I select the ID and the name of each of the students, unfortunately, notice there's a gap here in the IDs. And I don't know if you remember, but a few moments ago I created an extra Frank Jones and then deleted them. Now, even when you delete a row from the database, that ID will be lost. So it's carried on from where it left off with 3, 4, and 5. So that's a bit inconsistent with what I have here on the picture. So I will just update the picture at the top now to match the data we have in the database. Now, once we've set up these relationships, if I do a select of the ID, the name, and the tutor's foreign key from the student table, we can, of course, modify these relationships once they're set up. Let's say that we want to make it so that this Alan Matthews doesn't have a tutor anymore. We can update the student table and we can set the tutor foreign key to be that null that I mentioned before, which is just the keyword, no quote marks, where the ID equals 3. Let's see if that works. And now we know that that student doesn't have a tutor. I'll just update my picture at the top to reflect that. So that's okay. I can see just by looking by eye at this query that, for example, Claire Thompson is taught by the tutor of ID 2, and we know that that's Pat Fay. But I'm only doing that by I. It's only because I know that tutor ID 2 is Pat Fay that I was able to work that out. What I'd really like to be able to do is to do a select which gives me the information from both tables at the same time. I'd kind of like a list of all of the names of the students on the left-hand side, and on the right-hand side, the names of their tutors. Can I do that using a select? And the answer is yes. It's called a join. This is the syntax of a join. Now, the first thing to realize is that I want the names of the students, but I also want the names of the tutors. Now, both of those columns are called name. So what I need to do is to tell the database that I'm actually working with two different tables, tutor and student. And the way we do that is as follows. First of all, starting from the from clause, I specify that I'm selecting from both the tutor and student table. But this T and S is a little bit strange. It's called an alias, and it's really just a little label that I want to give to each of the tables. And I'm going to use that label elsewhere in the query. For example, here in the select statement, I'm wanting to select the student's name, or I should say, I'm wanting to select the name column from the student table and the name column from the tutor table in that order. And the S and the T here are just those labels that I declared in the from clause. You'll see that it's quite common for database people to abbreviate the tables with a single letter. If that's okay, then the where clause is the important part of the query. What I'm saying here is I only want pairs of names where the student's foreign key matches the tutor's ID. This query is going to find a list of all of the students that have a tutor, and it will return that tutor's name. And along with the student's name, it will also return the tutor's name. If you're interested in the mechanics of what's supposed to be going on under the hood, the database creates a list of rows with all the possible pairings of students and tutors. So we have rows for Frank Jones paired up with every single tutor, Alan Matthews paired up with every single tutor, and so on. Then in the columns here, these are the values that we're checking in the where clause. The tutor foreign key for Frank Jones is ID 1, and the ID of the tutor in that row is 1. Whereas in the second row, Frank Jones against Pat Fay, the foreign key from the student is 1, and the tutor's ID is 2. And it continues. And then in the final step, just the matching rows are returned. So this row here, we have a match of 1 and 1. So we will see Frank Jones and Mark Watson. We have a match on this row, Claire Thompson and Pat Fay. And we have a match on this row. So that's the theoretical process going under the hood. Actually, most databases will implement that in a more efficient way, but that's kind of the mathematical way that a join works. But notice that it only returns students that have a tutor. Alan Matthews in these two rows here, because their foreign key is null, they will be excluded from this report. Let's see if it works. So I want to select the student name followed by the tutor name from the tutor table, which we're calling T, and the student table, which we're calling S, where the student's tutor foreign key matches the tutor's actual ID. Now, they're not easy to write, I don't think, joins. They do take a bit of thought. But let's see if it works. And that, I think, is as expected. Put my data up at the top. We know that Frank Jones is taught by Mark Watson, Claire Thompson is taught by Pat Fay, and Suki Webster is taught by Mark Watson. Now, in the database terminology, this type of join is called an inner join. For many years, databases implemented this type of query in slightly different ways. So there is now an ANSI standard on how to do inner joins. And it looks like this. It does exactly the same thing as the query we've just seen. We're selecting from one particular table, but we are performing an inner join on a different table. And we also have the phrase on instead of a where clause. The ANSI committee just felt that it was more natural to have a special keyword for joining the keys together rather than using where. Now, I'm not sure if we actually use this on the course, so it's only for interest, but we can try that out as well. Select the student name and the tutor name from the tutor table called T, but we are inner joining on the student table, which we're calling S, on the student's foreign key to tutor, matching the tutor's actual ID. Well, I hated reading that out. I hope it makes some kind of sense to you. And the key thing is, it's returning exactly the same data. Both of the queries we've just done are inner joins. And the key thing about an inner join, it will only return a row where there is a matching value on the other side of the relationship. So unfortunately, poor old Alan Matthews is omitted from this query because they don't have a tutor. So if you do want to include the students that don't have a tutor, then you use the opposite of an inner join. It's called an outer join. Now here, the student table is the so-called outer table. The table in the from clause is the outer table. And with the outer table, we will get the rows back that have a null in the foreign key. Otherwise, the syntax is the same as the inner join. I'll talk about what left means in a moment. But really, we're just replacing the word inner with left outer. So let's try that. I'm going to hate typing this, but the student name and the tutor name from the student table S. So that's the outer table. And even if there are rows in this table with no relationship, they will still be returned by the query. But now we specify left outer join on the tutor table, which we'll call T, on the keys matching where the tutor's foreign key is equal to the tutor's actual ID. And the difference this time, excellent, is that all 4 students are returned. Where the students have a tutor, we get the tutor's name, but where the student does not have a tutor, we will see a null. It's called a left outer join because as you read this, the outer table is the one on the left-hand side of the expression. The right-hand side is the tutor table, and that's the table that we're joining on to. You can do a right outer join, which would make in this case, the tutor table be the outer table, and that would return tutors even if they have no students. But most people seem to stick with left outer joins because that's kind of just a natural way of thinking. And certainly on this entire course, we'll only be using left outer joins. So that's it for SQL. You certainly don't need to be an expert in SQL to study this course. If you've got a reasonable understanding of what you've just seen, then you're going to be fine. And we're going to be seeing a lot of these inner joins and outer joins through the rest of this course. Although, to be honest, for the most part, Hibernate will be doing the hard work of generating them. So that's it for SQL. I think I can hear music playing now. So there are a few other types of query that you can do, but as I say, we won't really need them for this course. So feel free to pick up any good SQL book if you're interested in learning more. I hope you're all up and running without problems. Don't forget we can help you if you're stuck. We give limited support in that we can only help you with the course content, but we really want to make sure that some minor problem doesn't stop you finishing the course. Don't forget the errata page on our website as well. I hope your IDE is all set up. You don't have to use Eclipse, but it will make support simpler. If you're not in Eclipse, you probably just need to make sure the jar files are on your IDE's build path. The SQL section was optional, it's quite basic, and I'm sure it wasn't 100% accurate, but it will be enough to carry you through the course. In the next chapter, proper Java programming, we'll see how we can translate a regular Java class into a database class. Rejoin me for that.